Example 4 is actually going to be very, very similar to the previous example in that we're going to be given the graph of a function f of x, but now we're going to be kind of given 6 different possible choices for what the derivative of that graph might look like. And we just have to try to identify which is the correct one. So this is kind of like a multiple choice question. Now, we can figure this out kind of working in the same way that we did previously. Why don't we start by taking a look at this picture and identifying some easy points to go ahead and kind of fill in our table of values. So that is, we need to pick some x values and find slopes of tangent lines that go with them. So maybe we can start with all the times where it would look like we would get a slope of 0. That's what we did in the last example, and I think it's a really great way to start on questions like this as well. So maybe like right around here, I could imagine getting a tangent line with a slope of 0. I might be able to imagine somewhere around here getting a tangent line with the slope of 0. And maybe even over here getting a tangent line with the slope of 0. Now if I want, I could think about, I should think about the x values that go with each of these slopes of 0. It looks like the one on the left maybe occurs around -1. This guy here occurs around 2. And maybe this one here occurs around like, I don't know, like 3.5. So with this information alone, I might be able to go ahead and start figuring out which of these graphs is at least no longer going to be in the running. Because I recognize that I should have the points -1, 0, 2, 0, 3.50, or at least roughly something like that. So let's see. What about this first graph? This has points of, or has a -2, 0, like a half 0, and maybe like 3.20, right? But it doesn't seem to have any of these points on it. So I would say right away that this is a bad choice, probably not the picture that we're looking for. What about this picture here? This crosses roughly around -1, 0, around 2, 0, and around 3, 0. So I have these points here which almost seem to match up really well with this. Okay, so maybe this is a good answer. Let's double check all the other ones just to make sure. Here I kind of cross at these points. And do these points kind of match up with the ones that we have up here? It doesn't look like it here. I have a 4, 0, a 2 point something 0. Like, nah, that seems pretty bad. Notice same thing kind of over here. Nope, that looks pretty bad as well. This point, or this graph, I cross around there, around here, and around there. So yeah, it's like -1, 2, and 3.5. So this is in the running as well. Let's check the last one just to be sure. This doesn't seem to be working out very well. I cross it like -2, maybe a half, and 3 point something. So, okay, so wow, with just that information alone, we've already narrowed things down to just 2 options. Now, obviously, these options here are different. One of these graphs starts high and ends low, and the other starts low and ends high. So how could we figure out which one is maybe the better choice? Well, that might just be in time then to choose another value of x and start thinking about some other tangent lines. Maybe let's think about what happens over here at the value of -2. Notice at the value of -2, I should be able to draw a tangent line that has a particular slope that, well, I guess the best we could say is that it's some positive number. So I know that on the picture of the derivative, I should have -2 and a positive y value. So notice if I go down to the picture here, I have -2, and definitely I'm going to get like a positive y here. So this is still in the running. Here I'm going to get -2 and, ooh, a negative y value. This could no longer be the graph of the derivative. So it seems like the only choice that works is this option here at the very top right. So again, I'm using the same ideas that we did in the last video, which is that I'm taking a look at different values of x, and I'm thinking about the slopes of tangent lines that happen there to try to get a rough picture of the derivative.